Okay, today we need to start in section 3.3. There's one thing that we skipped in 3.3 because we didn't use it at the time. So I skipped it on purpose, and now we'll be using it in 3.4. It's this first learning target right here. I can use the change of base formula to rewrite and evaluate log expressions. Okay, so here's the change of base formula right here. Okay, let's take a close look at it. What is it asking us to do? It says, when I have log base a of x, what I can do is choose any base I want. I take the log of the argument on top and I divide it by the log of the base. And how is that helpful? It's helpful for plugging things into the calculator. Our calculator is only programmed for base 10 and base e. Okay, so here's what I mean by this. Let's go down to example 1 and let me walk you through this. Change of base formula says log base 3 of 20. You may or may not have the ability to plug that in the calculator right now. If you have a brand new one, you might be able to. Okay, but change of base formula works for everybody, no matter what calculator you have. So what I can do is write this as log of the argument. So log of 20 divided by log of the base. Okay, and that's why they call it the change of base formula. I just changed it from base 3 to, remember, if it's not there, it's base 10. Or another way to do this is to also use the natural logarithm. I could say ln 20 divided by ln 3. Okay. All right. And then I'll show you how I can punch this in now. You know, at this point, we can only just guess, right? We're supposed to know that when we evaluate logarithms, it's 3 to the what power is 20. 3 to the third is 27. 3 squared is 9. So the answer is supposed to be between 2 and 3. Okay, but this will pinpoint it for us. Remember, the log and ln buttons are right here. Okay, so I can do this. Log 20 divided by log 3, and I get an answer just like that. Okay, and like I said, I can use base e if I want. So if I do ln 20 divided by ln 3, I'm going to get the exact same thing. Okay. So what did they say? They didn't say how many decimals. I'll just grab a couple, 2.73. So this would be equal to 2.73. Okay, go ahead and pause, and you guys try examples 2 and 3. Write down what you're punching in the calculator, and then write down your answer to 2 decimals. Okay, go ahead. Okay, here's your feedback. Looks like I wrote it down to 3 decimals, but whatever you chose, just make sure we're getting about the same answer. Maybe you put 1.16. And of course, you got the option of doing base 10 or base e. And we're going to get the same thing. Okay, so that's all we needed to do for 3.3. We needed that skill, and we'll use that skill in this next set of problems here in today's learning target 3.4. So let's turn there now. All right, 3.4, exponential and log equations. So today we're going to focus on the exponential equations, and we'll save the log equations until tomorrow. Okay. Now, there's 2 types of exponential equations we're going to see. We've actually solved some exponential equations when we can work towards the same base. All right, so solve each exponential equation by expressing each side as the power of the same base, and then we can use what's called the one-to-one property, which is right here. Okay, if we have the bases the same, then we just set x equal to y or u equal to v is what we said before. Okay, so let me just take you through a couple of these review problems. I don't think we need all 4. I'm going to take you through 1 and 3. So once you start playing with the powers of 2, we should be able to take that bigger number and break it down to a base of 2. Okay, that's what, 2 to the 5th? 2 to the 6th. All right, so 2 to the 6th is 64, so I just replace 64 with what it's equal to. Now I have the bases the same, so now we can set the exponents equal to each other. And sometimes we have to solve the result, but in this case, it's just x equals 6, so that's the answer to the problem. Okay? Sometimes they're that easy. Sometimes they're a little more involved, like number 3. In this case, we can rewrite both sides with a base of 5. So right now I have 1 over 5 to the first power. I can write that as 5 to the negative first power. Right now, I'm going to ignore the radical for a moment. I'm going to take 125 and write that as a base of 5. Because 5 squared is 25, but 5 to the third is 125. Okay? These are definitely steps you can handle or should be able to handle. All right, almost there. On the left, I have a power to a power, so I need to know to multiply that. So we get negative x. And on the right side, we need to go from radical form to exponential form. Remember, it's a visible index. It's a root 2, right? Square roots. So we should write that as 5 to the 3 over 2. Now we can set the exponents equal to each other and solve the results. So negative x equals 3 halves. So multiplying both sides by negative 1 will give me x equals negative 3 halves. Okay? All right, so I don't think we need 2 and 4. There's some extra practice there. This is review. We have solved some exponential equations before. But these messier ones are things that we haven't done, and that's what we're going to get into now, okay? So first thing I want you to do is to solve exponential equations using the inverse property. That is one strategy. I'm going to teach it a slightly different way. Please just write this down instead. Solving them when working towards the same base isn't reasonable, like the strategy we just did. All right, and then here's the steps that I want you to write in as the success criteria. Okay, so I'm going to pause to save some time in the video. You should pause too as you're writing this down. All right, so the COB means change of base formula, the one that we just went over. And this is just kind of our goal when we're trying to isolate the exponential part. You'll see what I mean when we get into it. Okay, so for number 5, to solve the exponential equation algebraically, give your answer to 3 decimal places if necessary. So here's where it's not reasonable to do what we did in examples 1 through 4. How are we going to rewrite 90 with a base of 3? We can't do it. All right, so it's not reasonable to do that. So we're going on to this new success criteria. So step 1, isolate the exponential part. It already is. Okay, and number 6, it's not. We got to get rid of the 5. Okay, so step 1 is done. Check. Step 2, converts to log form. All right, so we got to use these skills from last section of converting from exponential to logarithmic form. The base of the exponential part is your base of the log. So we say log base 3 of 90 equals the exponent. Some of you guys need some work on this. Go back to 3.1 or 3.2, because on the semester exam, we weren't perfect at that. But we should be at this point. Okay, so convert it to log form, and then step 3, use the change of base formula now. Up to this point, we didn't know how to punch this in, unless you have a sophisticated calculator and knew how to do it. But a lot of you didn't. But now we can plug this in using the change of base formula. We say log 90 divided by log of 3, right? Everybody just did that. Okay, so we're going to go to our calculator and just plug that in and see what we get. So log 90 divided by log of 3. And that gives me 4.096 if I round to 3 decimals. So I have 4.096 equals 2x. Everybody got that, right? Change of base formula. All right, now it's real simple, right? Just a pre-algebra step left, divide by 2. So I'm going to take half of that, and it gives me 2.048. There we go. Okay, example 6. Now we actually have to isolate it. We just want a base raised to an exponent, and it's close, right? I've got the 5 I just need to get rid of. So step 1 here would mean we want to divide by 5. All right, so now step 1 is done down here. I have e raised to the 2 minus x equals 6. What's step 2? Convert this to logarithmic form. Can't do anything anyways, right? When a variable's up here, we're stuck unless we can do something like this. Step 2. Now, we can write this two different ways. First, I'm going to write it as log base e, just so we're putting everything in the right spot, of 6 equals the exponent. Okay? Now, when we see log base e, we should know that that's natural log. So you could also write this as ln of 6 equals 2 minus x. I probably expect most of you to do that. Okay, and then it's up to you. You could actually use the change of base and do log of 6 over log of e, but there's an ln button already. So you don't really need to do that, right? We could just do ln 6 to get that answer, right? ln 6, and I'm going to get it. It's 1.792. So I have 1.792. And from here, everybody should feel comfortable with these algebra steps. Okay, so isolated, convert to log, step 2. And then step 3, I guess we could avoid the change of base formula since we already had the button in there. All right, so I'm going to move the 2 over. So that gives me, I'll just move over here. So minus 2, so that gives me, what, negative 0.208 equals negative x, and then divide by negative 1. So we get x equals 0.208 for the answer. All right, let's see what you can do. 7 and 8, I think you got the skills now to do it. Don't get ahead to 9. I'm going to replace with an application problem. But let's see if you can isolate those. Both of them need to be isolated. See if you can convert it, and then see if you can get an answer for 7 and 8. Go ahead. Okay, here's the feedback on 7 and 8. All right, so we need to get this by itself first. Step 1, isolate the exponential part. Move the 8 over. Divide by 4. Can't multiply 4 times 5 because order of operations says we're supposed to raise it to the exponent first. We don't know the exponent, so we can't do that. So divide by 4. Here we go. If you didn't have that isolated, write that down so you have that part. Okay, step 2 on your steps say to convert to log form. So log base 5, always keep the base the same, of this number equals your exponent is the pattern. All right, if you get here, you understand the change of base formula, just calculator work from here. Throw that in as log 7 over log 5. Okay, and then add 2 to that number. So we should get 3.209 once you do that. All right, here we go. Move the 15 over. Divide by 2. Now it's isolated. We can definitely convert this to log form. So maybe you wrote it like this, or probably just ln 6. And that's all you have left. It's already x, so we just punch that in, and we get 1.792. Okay. All right, we're not going to quiz you on problems that are quite like 9 and 10, but I want to replace 9 with an application from the book, and that's what we're going to finish with. So I'm going to pause while we're getting to this page. So everybody get to page 234, 71. I'm going to take you through the steps. All right, so this is a formula for compounding interest problems. They said the amount that is invested is $2,500, so that's P. And then they said part A for it to double. All right, so A is going to be 5,000 for the amount of the return, and they told us that 2,500 is the principal. Given information. Remember, E is just a number. It's 2.718. Raised to the R, so for 71, they said the rate is 0.025. And there's the time. Okay. I'll just show the solution in a moment because I'm about to be cut off, so I'm going to pause. All right, so there it is. Isolate, so divide by 2,500. So we get 2 on the left, and now it's by itself. Convert to a log, we get this. And then go to your calculator. Divide both sides by 0.025, and we get 27.7 years.